Hello, you guys, and welcome back. So, this week you guys only have 2 lessons, but you are going to have a quiz. Yes, I know, you're probably all panicking at the idea of having a quiz after last week's lessons, but don't worry, there aren't going to be any solving for the area of a regular polygon on there. I promise you, there's not a single question like that. So it should hopefully be fairly easy. It's all looking at area and circumference of circles, finding the area of a sector, finding the length of an arc, and looking at some inscribed angles and arc measures. So using that to take and solve for some things, okay? So I'll talk more about that in the second video, but that will be on Canvas. So you'll just go to our Canvas page, click on assignments, and it should show up under your upcoming or your current assignments that need to be done. It'll show up there. It will be shorter than our usual quizzes that we would have in class, but it is going to be a quiz, so it's going to be worth a decent amount of points. So make sure you try your best on that, okay? All right, so let's go ahead and get started. We are on 7.6. So looking at this first part, we are looking at measurement conversion and scaling. So below you'll find several measurements, convert them all to the units of feet. So we're converting inches, yards, and miles all into terms of feet. So we have our different conversions here. 1 foot is 12 inches, 1 yard is 3 feet, and 1 mile is 5,280 feet. So we are doing number 1 together. For number 1, we have 50 inches. So to go from our 50 inches to feet, the conversion is 1 foot is 12 inches. That means we're going to take our 50 inches and divide by 12, and that's going to tell us how many feet we have. And 50 divided by 12 is a 4.167 feet. So 50 inches is 4.167 feet. So there is your answer for the first one. So if you had yards and you needed to take and go to feet, you would multiply. If you have miles and you want to go to feet, you're going to multiply by 5,280. Yards to feet, you're going to multiply by 3. Inches to feet, you're going to divide by 12. So hopefully that helps. All right, for the next section, you're going to use the equation C equals 5/9 times F minus 32 to convert the temperatures. So we have 50 degrees Fahrenheit, and we need to convert that into degrees Celsius. So C equals 5/9 times 50 minus 32. 50 minus 32 is 18. So we're going to have equals 5/9 times 18. So now we could take and simplify this, or we could just plug it all right in a calculator. That's a little hard for you guys to see. Hang on a second. There we go. So if we take and do this, the 18 and the 9 will cancel. That becomes a 1. 18 divided by 9 is 2. 5 times 2 is 10. So 10 degrees Celsius. So 50 degrees Fahrenheit is the same thing as 10 degrees Celsius. All right, so now we're going to do the same thing with the 20. Now, 20 degrees Celsius, it's going to go first. So we're going to have 20 degrees equals 5/9 times Fahrenheit minus 32. So first thing we have to do is get rid of the 5/9 by multiplying by 9/5. That cancels out, so we're left with just F minus 32 on this side equals, now, just like I did over here, because the denominator and whole number are divisible, we can cancel those. So divide both of them by 5, that becomes 1. 20 divided by 5 is 4. So now we have 9 times 4. 9 times 4 is 36. So we have 36 equals Fahrenheit minus 32. So we're going to add 32. We add that over. Those cancel. So our Fahrenheit temperature is 36 plus 32. So we end up with 68 degrees Fahrenheit. So all you're taking and doing is going back and forth between those two different temperatures. So between Fahrenheit and Celsius. So if you have a Celsius, it's going to go first, and then you'll multiply by 9/5 and then add 32. The other way, you're going to take and subtract first and then multiply by 5/9. So you can plug those all right into a calculator to take and solve for your measures, okay? All right, the next thing we are looking at, let me shrink this back down. So on number 13, we are looking at arc length, arc measure, central and inscribed angles. So we've got a lot of different things going on in here. Arc measure is your key word for this lesson. So let that be known. Arc measure is your key word for this lesson. So on number 13, we're given that angle ABC is 110 degrees. We're also given that arc AE is 110 degrees. So we have a variety of different arc and angle measures that we're going to find. I have them all listed out. We are going to find all of them together on this one. So just as practice for you guys. Sorry, I have to fix it. I accidentally erased it just a second ago. Okay, so looking at this, the measure of arc AC. So that's this arc right here. Now remember, when we have an arc, and the angle that's cutting this arc or giving us this arc is at the center of the circle, the central angle and the arc measure are the exact same thing. So the measure of arc AC is 110 degrees. Now, the measure of angle ABE, so ABE is this over here. This arc AE has endpoints on this angle, and this angle is at the center. So if the arc is 110, the central angle also has to be 110 degrees. Excellent. Okay, now angle CBE. So once again, we're a central angle, but we don't know what the arc CDE is. But could we solve for it? Yes, we can. How many degrees are there in a circle? 360 minus 110, because that's how much we said arc AC was, minus another 110, because that's how much arc AE is, which is given, is going to equal what? Well, 110 plus 110 is 220. 360 minus 220 is 140. So because the angle is the central angle, the arc and the angle are the same degree. So it's 140 degrees. All right. The next one I have up here is angle ADE. So ADE is this one here. Now, notice this one has endpoints on the arc of AE, which is 110 degrees, but the vertex is no longer the central angle. Instead, it's inscribed on the circle. So what that means is the relationship is we divide by 2 when we go from the arc to the angle measure. So we're going to take 110 and divide it by 2, and we end up with 55 degrees. So angle ADE is 55 degrees. Now we're looking at arc arc ADE. So almost the entire circle, it's everything but this little arc AE. So what that means is we're taking the full circle, so 360, and subtracting everything else from it. So we know that arc AC we're subtracting the 110 because we want everything else. So we're taking 360 minus the 110. So 360 minus 110 is going to give us 250. So I end up with 250 degrees for that arc. All right, the next one I have is the measure of angle BAE. So angle BAE is this angle right here. So for this one, we're looking at taking, we have this triangle here that it's a part of. So BAE is within this triangle. We know this angle is 110 degrees. How many degrees are there in a triangle? 180. So 180 minus 110 equals what? Correct. It equals 70. Now, this angle is not 70 degrees, but AB and EB are both radii of the circle, which means they're the same length. And if we have two sides in a triangle that are the same, that means it's isosceles, which also means the base angles are also the same measure. So these two angles have to add up to the 70. So that means we can divide by 2. And 70 divided by 2 is 35 degrees. Excellent. All right, so that was BAE. Now we have the angle BEA. So it's the other base angle in this triangle. So what do you suppose its degree is going to be if the other one was 35? 35. You got it. All right, our last two, we have angle BCE. So BCE, so once again, we've got a triangle over here. This one though, remember, this angle here, our angle CBE, so CBE was 140. So here we're going to take 180 minus 140. 180 minus 140 is 40. Now, same thing as with the last one. The two sides of this triangle are the radii of the circle, which means they're the same length. So that means the base angles are the same. So that means we're taking this 40 and dividing it by 2. 40 divided by 2 is 20. So this angle is 20 degrees. And the last angle, the measure of angle BEC, which is the other base angle in that triangle. So its angle measure is 20 degrees. You got it, because they have to be congruent. So those are our relationships with arcs and angles. So you're going to have a section on your quiz that is similar to this. So having arc measures and finding the angle measure, or having the angle measure and finding the arc measure. Now, obviously, there were a lot of parts to that problem right there. You're not going to have that many parts on your quiz. On your quiz, in any given figure, you're either going to be solving one or two different angle measures or arc measures. So you're just looking for two different things in the ones that I'm going to give you on the quiz. So it'll be significantly easier, okay? So don't worry about that there, alrighty? All right, so that's what you're looking at with that section, is looking at those arc lengths, arc measures. Remember, arc measure is your keyword for this lesson, and central and inscribed angles. Now, for 15, yes, I'm going to be nice and do 15 with you guys. You're welcome. So 15, there's a lot going on, obviously. We have 3 different circles, and we have a whole bunch of line segments going on in amongst all of that. So it looks very, very crazy. But what we want to take and figure out is, oops, hopefully that'll go away. Sorry. In the figure below, given that triangle JKL, so that's this triangle right here in the very center of all this mess, is an equilateral triangle, list all of the angle and arc measures that you will know for sure as a result of this given item. So because this is an equilateral triangle, that means all 3 of those angles there are 60 degrees. So we're going to go ahead and list out those 3 angles as angles that equal 60. So we have 4 different measures that we're going to be stating things for, but we're going to have a lot of different angles and arcs underneath each of these. So for angles that equal 60, we're going to have angle JKL, angle KLJ, and angle LJ. Okay, sorry, got a little confused on that one. Okay, now with those three angles being 60, we have other angles we can find in here. We have a couple pairs of vertical angles. So if we look, this angle here, our angle KLJ, is right across from the angle ALB. So that means this angle right here where my mouse is also 60 degrees. So we're going to have angle ALB. Now we go over to where the vertex K is. So we had the angle JKL. Guess what? It's across from another angle, which means vertical angles, and vertical angles are congruent. So we've got the angle EKD. So there's another one. Now we had three angles here in the center that were 60. So guess what? We've got another one. So we knew that LJK was 60. The angle across from it's also going to be 60, and that is angle HJG. Oops. So those are our 6 angles that are 60 degrees. So now we're going to look at the angles that equal 90 degrees. So if we look in here, let me scooch this over a little more. We've got this right here, HLK. If you notice, it forms a right angle. So angle HLK is 90 degrees. That also means that angle DLJ is 90 degrees. And also LKG is 90 degrees. And one more that we're going to state is angle LJE. I know there's a lot of different lines going on in here, so it's understandable if you get a little confused with finding these. That's why we're doing this one together, because like I said, there's a lot of different parts going on within this figure, so trying to make it a little easier on you guys. All right, the next one that I have are angles that equal 30 degrees. So we have a decent amount of those. So angle JHL, so this angle here. And angle HLJ. So isosceles triangles, remember the base angles are always going to be the same. So angle HLJ. So then JGK is going to be 1, same as JKG is going to be 1. So angle JGK and angle, oops, where'd it go? JKG. And then, let's see. We also have angle JEL is 30 degrees. And then angle KDL is 30 degrees. And angle KLD. So once again, that isosceles triangle in there. So KLD. So those are all our 30 degree angles in there. Now we just have a few arcs to take and look at. So thinking back to our vertical angle here, so because This is a central angle, and it's cutting. We've got the arc AB, that's going to be 60. We also have the arc ED that will be 60. And we have the arc HG that is also 60. So those are a couple arcs. We also have the arc JK, which is 60, because that's part of the circle still. So JK. That means we also have, let's see if I can see it. That means we also have LK. Yep, this part right here. So like I said, lots of lines going on in here, so it can get kind of confusing where things are. So arc LK. And last but not least, arc JL. So those are all the different arcs and angles that we can for sure calculate within this figure. So hopefully that helps you guys a little bit with that. You will be doing 16 on your own. I'm not going to do all of them with you. So 16 in the figure above, given that triangle JKL is equilateral and each side is 5 units in length, list all of the segments and arc length measurements that you will know for sure as a result that's given. So do your best, give as much as you can possibly figure out. Obviously, I know there's a lot going on in there, so it can get pretty confusing, but do try to give as much information as you possibly can. Excuse me. All right. Okay, this last section here that we're looking at for this lesson is finding the area and the perimeter. So note area and perimeter. You're doing both parts. Don't only do one or the other of each of the figures below. So obviously these are not regular figures. That means you're going to have to decompose. So you're going to split this figure into probably 3 different parts. You're going to have a rectangle here, you'll have a rectangle here, and then you'll have a hemisphere. We're going to do 18 together because obviously there is a lot of shapes going on in 18. So we're going to do that one together to try and make this as easy and understandable as possible for you guys, okay? All right, so first of all, in 18, I'm going to start by finding the area of this large rectangle here, so the 40 by 35. So the area of that large rectangle, we've got 40 times 35 is going to equal that area. So we're going to take and multiply those together. So we end up with 1,400. And our units is centimeters squared. Oops. So you can see that. Okay, now I'm going to find the area of the triangle, but I don't have all the necessary information. I know the hypotenuse is 40 because opposite sides in a rectangle are going to be the same, but I need to know what the perpendicular height is to find the area of the triangle. So that is actually the work that I did here. I did that ahead of time just to save some time with you guys. So I used the Pythagorean theorem. So we've got 24 squared plus x squared equals 40 squared. Like I said, that hypotenuse is the same as the 40. That's the other side of our rectangle. So 576 plus x squared equals 1,600. So we subtract the 576 from both sides. We end up with x squared equals 1,024. We take the square root, so x equals 32. So we know what the perpendicular height is in this. So area of a triangle, so we're going to have 1/2. The base is 24, so times 24 times our height, which we just said was 32. So 24 times 32 gives us 768. Divided by 2 will give us 384 centimeters squared. Okay, so now we have the area of our rectangle and our triangle. Now we need to take and figure out the area of our 2 half circles. So our first half circle I'm going to do is this one over here that's off the triangle. So the diameter of this is the height of our triangle. So our height was 32, so the diameter is 32. Well, we need to know the radius. So 32 divided by 2 is going to give us 16. So area equals pi 16 squared. So we're going to take 16 and square it, which gives us 256, and then times that by pi. So we're going to end up with 804.25. Now, that is an approximation for that, since I did have to round these to the nearest hundredth. That'll be the easiest for you. All right, so that's the area. That'd be the full area if this was a full circle. But is this a full circle? Nope. So what are we going to have to do? We have to divide it by 2. So I'm going to take this and divide it by 2. So 804.25 divided by 2 is going to give us 402.125 centimeters squared. Now we do the area of the half circle, number 2. So that's this one over here. Now this one, its diameter is the same as the other side of our rectangle, which is the 35. So half of 35 is 17.5. So area is going to equal pi of 17.5 squared. So we're going to take our 17.5 and square it. And we end up with 306.25, and we multiply that by pi. So we end up with 962.11. Now, once again, is that our final answer for the area of that circle? No, because it's not a full circle, so we divide by 2. So 962.11 divided by 2 gives us 481.06 centimeters squared. So lots of parts to this. So now we need to take and figure out the total area. So that means we're going to add all 4 of these values together. So we've got the 1400 plus the 384 plus the 402.125 plus the 481.06. So add all those together. So I'm doing it in the calculator. 1400 plus 384 plus 402.125 plus 481.06. And we should end up with 2,667.185. So 2,667.185 centimeters squared. So there is our area. Now, to find the perimeter, we have to add all the lengths on the outside. So we've got the 40, we've got the 35, and we have the 24. So we found each of those. Those are already given to us, so I started by writing all those out. Now, the other 2 parts are the curves of our circle. Now, what that means is we need to find the circumference of each of those 2 circles and then cut it in half. So we're going to have 1/2 of, well, what's the diameter of this first circle over here that was next to the triangle? 32. So 1/2 times 32 pi plus 1/2 times, what was the diameter of our other circle? 35 pi. So now we find out what those are. So half of 32 pi, is 50.27. So we've got 40 plus 35 plus 24 plus 50.27 plus half of 35 times pi is 54.98. Now we take and we add all those together. So 40 plus 35 plus 24 plus 50.27 plus 54.98. And we end up with 204.25 centimeters. So there's our answer. So obviously there's a lot, whoops, didn't mean to click off of there. Obviously there's a lot going on in these problems, 18 more so than 17. So 17, you're just gonna have 3 different shapes that you'll have to find the area of and add together and then calculate your perimeter. So definitely be careful as you're taking and doing that, and be careful about what your figures actually look like. Remember, our key word for this lesson was arc measure. If you guys have any questions, feel free to send me an email. I'll try to get back to you as soon as possible. If you need any help, office hours, Monday, Wednesday, Friday, 1 to 2. Good luck. Remember, there's only 2 lessons this week and then a short quiz over 7.1 through 7.7. All right. Have a wonderful week and happy mathing.